Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the February-March 2020 Pure Mathematics 2 paper from Cambridge 9709. And this question here is about numerical methods and iteration and a bit of differentiation here as well. So it says a curve has equation y equals x cubed times e to the power of 0.2x, where x is greater than or equal to 0. At the point P on the curve, the gradient of the curve is 15. So part A says show that the x coordinate of P satisfies this equation. X equals the square root of 75e to the power of negative 2x all over 15 plus x. So this question here is telling us about the gradient of this curve. Okay, so it says the gradient of the curve is 15. So they've told us the equation of the curve is y equals x cubed times e to the power of 0.2x. So the gradient function is when you find dy dx. So what we need to do is we need to find when dy dx is equal to 15. So the first step is for us to find what dy dx is. Now here we have a product of two separate functions. You don't have a function inside another function. You have a product of two separate functions, and the rule that applies for differentiation, if I have, for example, a function and I have another function added to it, I can differentiate the first function with respect to x, and I can differentiate the second function with respect to x, and that's fine. I can add the two separate differentials together. But when you have a function times another function, that doesn't work. You can't just differentiate x cubed and differentiate e to the power of 2x, e to the power of 0.2x, and multiply the two differentials. You have to use what's called the product rule. Okay, so that's very important for us to understand. Now for the product rule, we're going to call one of the functions u and the other one v. So I'm going to say u is equal to x cubed and v is equal to e to the power of 2x, 0.2x. Then we have to differentiate the first function. That's going to give us 3x squared. And we differentiate the second function. That's what the dash part means. And that's going to be, now e to the power of something differentiates by staying the same. Doesn't change. But then you have to multiply by the differential of what's inside the function. So we have to write 0.2 e to the power of 0.2x. So this is the part where it stays the same. And then you multiply by the differential of what's inside the function. This is because of the chain rule. So you have 0.2 e to the power of 0.2x. Now, for dy dx, what we do is we multiply these two together. So we have 3x squared times e to the power of 0.2x, and we add these two multiply together. So we have plus x cubed times 0.2 e to the power of 0.2x. So I'll write it like this. I'll write it as 0.2 times x cubed times e to the power of 0.2x, and we know that that is now dy dx, and that's equal to 15. We're going to find when that's equal to 15. Alright, so now basically we have to rearrange this to become the same as that. So what they've done obviously here is they've multiplied by 5 to get rid of this fraction. This is like 1/5. So let's do that first, get rid of the fractions. So that becomes 15 x squared e to the power of 0.2x plus x cubed e to the power of 0.2x equals 15 times 5, which is 75. Okay, and now they've made the x squared the subject of this formula. Okay, so they've taken out the common factor from these two terms, which is x squared times e to the power of 0.2x, and inside here we're left with, in this case, 15 plus, and that'll be x, factorizing those out, equals 75. So now we can see that we have divided both sides by all of this. So you have x squared equals 75 over e to the power of 0.2x times 15 plus x. Now what's happened here, if you see how this looks, the e to the power of negative 0.2x is on the numerator. So they've just written this using the index form. We know that, for example, a to the power of negative n is the same as 1 over a to the power of n. So they've written this in the numerator with the negative power. So it's 75 e to the power of negative 0.2x over 15 plus x, and finally they've taken the square root of both sides. So you have 75 e to the power of negative 0.2x over 15 plus x, and that's exactly what we had to show. Okay, so there's part A of the question. Now this part of the question is mainly to do with differentiation, and we had the product rule here. Now part B of the question is more to do with numerical analysis. So what I'm going to do is I'm going to actually save this part A as a separate video, because part A is to do with mainly differentiation and you know, using the product rule. And part B is mainly to do with numerical methods, and part C is to do with integration. So I'm going to save these in 3 separate videos so I can categorize them into the 3 separate playlists which they're related to. And I'll put links to the other parts at the end of the video as well. So I think I'll do that. So that concludes this particular video. Other questions from this particular paper can be found in the playlist that will appear in the top right of the screen at the end of the video. If you want to watch part B of this question, you can click on this link here. This link will take you to differentiation and from P3. Okay, differentiation from P3, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.